4:35.
Just 2 minutes. Just wait for 2 minutes.
Okay, no problems. Absolutely.
Professor Tiwari, namaskar. We can start now.
Yes, you can start.
Tiwari, namaskar.
Shurujitda, welcome. Shurujitda, come.
Okay, thank you, thank you.
Yeah. Okay, Professor Samanto, it is, I think my watch, it is already 4:35.
Yes, you please start, please.
I'm not going to start, it has to be by Professor Bera. So,
okay. Now, Professor Bera,
yeah.
Welcome address to this audience.
Yeah. So, once again, may I all of you to kindly put your video off, because we have to ensure that the bandwidth is not a problem. So please put your video off, and also your audio in the muted stage, and only the speaker and the coordinator may go on. Rest everybody should put your audio in the muted mode. Yeah.
Hello.
Okay.
Amal Kumar Raychaudhuri was an Indian physicist known for his research in general relativity and cosmology. Most significant contribution, the eponymous Raychaudhuri equation, which demonstrates the singularities arise intuitively in general relativity and is a key ingredient in the proofs of the Penrose-Hawkins singularity theorem. The term Raychaudhuri equation made its maiden appearance in a research paper published in 1965 by George F.R. Ellis and Stephen Hawking. The Raychaudhuri equation hit the zenith of fame as it was a key tool in the hands of physicists like Stephen Hawking and Roger Penrose in 1960 in their attempt to answer the question on the existence and to explain the theory of the universe. There is such wide acceptability of this equation, like other notable equations in physics like the Dirac equation and Motion, that nobody cares about the publication. The Raychaudhuri equation paved the way for later research into the singularity problem. It is no and believes that the equation will stand firm so long Einstein's general theory of relativity stands. The equation remains a prime tool to investigate the behavior of black hole horizon. Needless to say, one would wonder if there is any research work of such grade to have emerged. in the post-independent India. Welcome with everyone in my heart, all of you to this program, and also cherish that it will carry the very signature of AKR Chaudhuri. Before I wind up, I would also like to extend my deep tribute to Professor Raychaudhuri and thanks once again, one and all associated with the program. Thank you all once again.
You have not unmuted yourself. Please unmute. Please unmute, Professor Das.
Sorry. Thank you, Professor Chakraborty. Okay, so thanks once again to Professor Bera for your welcome address, and once again a warm welcome to everybody who are present in this special webinar. All the dignitaries, all our friends, all the students and participants. We are having today a very special webinar to discuss the life and works of one of the most original and unique scientific minds from our country, Professor Amal Kumar Raychaudhuri. The name is being widely discussed today, in particular, especially after the announcement of the Nobel Prize in Physics this year, which, as you all are aware, it has been awarded partly to Professor Penrose, and the citation of the Nobel Committee says that it is for the discovery that black hole information or black hole formation is a robust prediction of the general theory of relativity. Now, the seminal work on black hole singularity by Penrose and Hawking, published in the mid-60s, made use of the famous Raychaudhuri equation, which is a key ingredient to explain the space-time singularities and gravitational focusing property in cosmology. AKR, as he was known to the students, had written his famous formula way back in 1953 and published it in 1955 when AKR was in the Indian Association for the Cultivation of Science. And if you see the year, that was more than a decade before the Penrose-Hawking seminal work got published. Well, while Raychaudhuri equation came into spotlight, as can be seen from the large number of articles that are appearing, today's webinar has some speciality, and I must mention that. Some of us present here, both as speakers as well as listeners, are fortunate enough to have got Professor AKR during our college and university days. So we are really thrilled at this opportunity to share with all of you, especially the students who are present in this webinar, the life and science of this great scientist and the humanist, and also we pay homage to our revered teacher. I would like to express my thanks to Professor Bera and the Midnapore College CSC team, and also our IAPT RC15 members for jointly organizing this grand event. Now, just one or two words about the format of our today's session, as you can already see from the announcement. So, first, we are going to have some brief introductory remarks on Professor Raychaudhuri from Dr. Achito Pal, who was actually a student of Presidency College, and now it is Presidency University, and who had attended AKR's lectures during his BSc as well as during the MSc years. That was a time when AKR used to teach us quantum mechanics and other subjects. Incidentally, I must mention that Achin had a brilliant academic record all throughout in Hindu School, Presidency College, and then Science College. Subsequently, he joined Partha Institute of Fundamental Research, from where he completed his PhD. If I correctly remember, it was 1983, if I correctly remember, but Achinto may correct me if I'm wrong. And then he joined ONGC, where he spent a large chunk of his professional career as a geophysicist. Well, he is currently the secretary of our IAP RC15. Without wasting any further time, may I request Achinto to take over and do what we call in Bengali Sriti Romanthon, okay, about our teacher AKR. Over to Achinto.
Okay, thank you so much, Professor Das. I think without wasting any more time, I'll start the presentation. Good evening to everyone. Just a minute.
Share your.
Just give me a minute, because it should come. Yeah, sometimes it doesn't appear, the particular presentation, so that creates the problem. Okay.
Yeah, it is coming now. Yeah.
Now it's coming. Yeah. So I will basically reminisce about our teacher AKR as I saw him. She was born in 1923 and passed away in 2005. His work and achievements, of course, will be discussed in detail by our next speaker, Professor Partha Sarathi Majumdar. I'll just say that Professor AKR Raychaudhuri had to fight against many odds, both financial and professional hurdles, like many. However, like Professor S.N. Bose, he was fortunate. Many contributions have got suppressed. So here is Professor Raychaudhuri with other luminaries of Presidency College with 1967-70 batch and faculty members in Presidency College. On the right of Professor Raychaudhuri is Professor Samarendra Ghoshal, who was the head of the department during that time. Now I'll start off with the troubled days of political turbulence in early 70s when we got admission to Presidency College. We were, in particular, I was there from 1970 to 74 and then in MSc from 1974 to 77. Now, recounting those troubled days, I'll just share with you that due to the disturbances, persistent disturbance in the Presidency College, I had decided to go to take admission in St. Xavier's College. But the day I was about to take admission into St. Xavier's College, from the tram, I noticed that the police picket has been removed from Presidency College. So I got down from the tram and then continued to Presidency College. Now, after 50 years, I feel fortunate that I took that decision, that instantaneous decision. Otherwise, I would have lost the teachings of the likes of Professor Samarendra Ghoshal, of course, Amal Kumar Raychaudhuri. Now, this is the Presidency College, first floor of Baker Laboratories. The physics department was situated, and of course, the corridor of physics department. The reason
1 minute or two. Please do not share. Somebody is sharing. Please avoid sharing your slides. Somebody is sharing the slides. Please do not.
So go read it, okay now?
Just a minute. Apurva Guche, do not share the slides. This is interfering with the speaker's slides.
Apurva Guchait, please press on stop presenting. That will do it.
Please come back.
Just a minute. No, this very disturbing. Pradipto, can you just
Yes, sir. I am telling to Dr. Samon.
try to him.
Yes, yes.
He's unable to go out. I mean,
No, actually, Apurva Guchait has pressed on stop presenting. That will do the job.
Please.
Professor Apurva Guchait, please press on. Okay, fine.
yeah. Okay. Go ahead.
I'll just go back by one slide.
Yes, please.
So should I continue now?
Yeah. You please continue. Yeah,
Okay.
please continue.
Okay, fine. So I'm showing, I've shown the corridor of physics department and the classroom, a typical classroom of Presidency College. Because in those period, so-called revolutionaries used to storm the classroom or the corridors to disrupt the classes. And the first thing which impressed me most in Professor Raychaudhuri was that he had the courage to face the rampaging, misguided students and gently persuade them to refrain from disrupting classes. He had eye contact with those rampaging people.
Watching to your screen.
Huh?
I think you are your screen. I think some of the people are saying that they are not looking at your screen. So
Should I go back and?
yeah, I think that will be better. Just go back and
No, this is okay. Resume. Here the resume had come. Okay. Okay, I think I'll stop presenting and then again restart.
Sir, please share screen afresh.
I did that.
Okay, sir.
Chinto, maybe you should stop presenting again. That would be easier for you.
Yeah, I think I should do that. Yes. Yeah, can you see it now?
Yeah.
Yes.
Yes.
yeah.
Yes.
Now it is okay.
Yeah, I think that was because of the disruption,
Yeah.
Yes.
So,
Yeah. Go ahead. Make it
okay,
full screen.
I'll
Make it
start from this slide.
Yes. Make it full screen, please.
Okay, so I'm showing this photograph of the corridor of the physics department and the classroom in Presidency College, in the physics department, just to mention that, during those times, the students used to, disrupt the classes. And what impressed me about Professor Raychaudhuri was that he had the courage to face these rampant, misguided students and persuade them to refrain from disrupting the classes. So he could do that effectively. Not always, of course, but he did that. Now, coming back to the courses that he gave, he taught us thermodynamics and the theory of radiation, among other topics, during undergraduate days, that is BSc. And I distinctly remember his correct pronunciation of Paul Lasva. Earlier, we used to pronounce Paul Langevin by the spelling, but he corrected us, saying that it should be Lasva of the theory of paramagnetism. And he taught us classical mechanics, so during the postgraduate days, and it turned out to be a landmark course which helped us in grasping the nuances of quantum mechanics later. So this is just unforgettable course, and he did write a book also on classical mechanics, I believe, based on his lecture course. And he, in a mechanics class, he would start writing by writing a big L or big H, the Lagrangian or Hamiltonian, and end up writing the equations, and his fonts would get smaller and smaller to hit the lower right corner of the board. So that was very characteristic of AKR. And this is a typical, his face while teaching. And then a memorable incident for me. After the untimely demise of our batchmate Narayan Chandra Rana, a famous astrophysicist later, many of you would know him. So he passed away in 1996. So after his demise, a film was being made on his life and work by our friend Amit Jana. So Narayan was a favorite student of Professor AKR, naturally, because he was already aware of Professor Raychaudhuri's work, even during the BSc days, while we are blissfully Professor Raychaudhuri's work. We used to only work on our, regular course and object-oriented. That means how we can get marks in the exam. But Narayan Chandra Rana went much beyond that. So Professor Raychaudhuri and I were among the 3 persons to be interviewed, and I, mainly because of my long association of 15 years with Rana. So I remember the shooting for the film was being done at my home, and he came in a gracious way, almost gliding in a gliding motion. That is the typical his gait, his students will remember. And during the recording, while I fumbled with my speech, which resulted in 3 takes, Professor AKR completed his interview in just 1 go, no retakes, and that too in impeccable Bengali, without any sprinkle of English words. And I couldn't resist the temptation of sharing a young AKR's picture, which I happened to get from the documentary which was made by Ayuka after Professor Raychaudhuri's demise. And I will acknowledge that film at the end. So this photograph I had never seen before, young AKR. Now, his unique and remarkable personality, as Bibhas Chaudhary, Vice President of the Presidency Alumni Association, said, Raychaudhuri's genius never reflected in his way of life. He lived very simply, always traveled by public transport and wore a dhuti kurta, a traditional Indian attire. He prepared minds. He never thought of his own career. Even in the interview, he himself said that he liked teaching, and instead of a full research career, he chose teaching as well. Now, the characteristic, as Bibhas Chaudhary said, that he almost always wore the traditional Indian attire. I am reminded of Satyajit Ray wearing our typical Bengali traditional dress while receiving the Legion d'Honneur award by French President Mitterrand in 1987. Likewise, Amal Kumar also was always seen in ethnic attire, as you can see in the pictures, maybe except during the foreign trips. So not only AKR taught a generation of students, he created a string of very bright students. He was also at the head of the Institute of General Relativity and Cosmology at Presidency College, as you can see. And he was so active that he produced a full paper even as late as in 2004. Now I will wind up his reputation as a teacher, because my theme was to present him as a great successful teacher. I will quote Praveen Roy, a senior professor of Department of Theoretical Physics. He has, of course, retired now from TIFR. So he, present nice story to illustrate Professor AKR's influence on the students, how much influence he had created on a generation of the students. So Professor Raychaudhuri usually rode a tram car from his home in South Calcutta and reached Presidency College, situated in Central Calcutta, in a tram. As somebody said, that he always used the public transport. And then, as this has also been shared by Professor J.V. Narlikar in a biography on AKR that he wrote in INSA Bulletin after AKR's demise, that there are today scientists all over India and abroad and other presidency alumni who at the same time came under AKR's teaching umbrella and have left empowered for it. So there is an account given by etc. So that account is given by Professor Praveen Roy. So he basically says that, they were so much impressed by AKR that they tried to know what is the secret behind AKR's talent and his grip on this. So then somebody reported that he had apparently seen that Professor AKR, after getting down from the tram and before entering the Presidency College premises, used to buy, which in Bengali is called the chanachur, meaning the roasted chickpeas, and he used to buy that and partake of that. So then, seeing that, the student also tried to, they tried to buy that same chanachur from that vendor, with the hope that that will also endow them with the talents of AKR. And Professor Praveen Roy has said that maybe whatever he could do in physics was because of that particular roasted chickpeas or chanachur. So Professor A.K. Raychaudhuri passed away on June 18, and this photograph, this is a snapshot taken from the film, and they say that it was before barely just 2 months after filmed with AKR. So this is what I wanted to tell all of you about the AKR as a teacher. And as my acknowledgement, I show this film, which was jointly produced by Inter-University Center for Astronomy and Astrophysics and Vigyan Prasar. And these are the list of, the advisory committee. You can see the people from UCA, including Professor J.V. Narlikar, and then Calcutta University and Jabalpur University and Presidency College. What I liked most about this documentary was that it included an interview with Professor
in the early 80s to work as a postdoctoral fellow. Then he joined as a faculty in Shah Institute of Nuclear Physics, I think in the mid-80s. And subsequently, he moved to the Institute of Mathematical Science, the Math Science in. And then again, he was back to Shah Institute in 2004 and stayed in Shah Institute till 2012. Now, during the past decade, he served as a senior professor in the physics department of Ramakrishna University, Belur, and then he served as a visiting professor for a little while in ISAR, Kolkata, and currently he is in IACS, as I have already mentioned, as a visiting professor. So in course of his academic career, covering a really wide canvas, Professor Partha Majumdar has published a large number of scientific papers in reputed journals. He has guided several PhD students and also has received a number of awards and accolades, which will take me too long a time to say. But most importantly, Partha is a phenomenal teacher. He's a phenomenal teacher who is loved by his students. And according to me, this is one of the greatest achievements. And I'm sure that Partha will also agree with me that apart from writing, really,
I see.
No, but you have to again. I'm really sorry to keep on reminding. Please do not share the screen when the speaker is speaking. I mean, this is something which is really, really very, very disturbing. I understand that people probably do it, by mistake. But do not press on that particular key, share screen. Do not do that. Please, request. Yeah. Now you are fine, Partha. Please go ahead.
Is this again visible to everyone?
Yeah. This is fine. Go ahead, please. Yeah.
Okay. So this is AKR, Professor Amal Kumar Raychaudhuri. My previous speaker, Dr. Rachintapal, mentioned in his very invitation. He was born in Borishal, Bangladesh, in 1923, and he passed away 18 June 2005 in Kolkata. About his education, he did his intermediate science from City College, Kolkata, and for his bachelor's, he was also a student of Presidency College. And of course, he was university topper. I mean, this is expected because he was firmly geared towards the study of physics and mathematics. There is a little story about his Master of Science, because you can see that his special paper is in X-ray crystallography. Now, AKR obviously had a preference for theoretical and mathematical. So why was he doing a special paper in X-ray crystallography? Well, at that time in Calcutta University in the physics department, there was an option of doing a theoretical dissertation in lieu of taking a special or two of the special papers. And there was a huge rush for opting for this dissertation. The rush was so big that the head of the department, who at that time was none other than Professor Meghnad Saha, he said that, look, there are too many people opting for this, so many people cannot complete a dissertation, so I shall conduct an elimination test. Now, as it happened, on the day of the elimination test, AKR came down with the flu. Not COVID-19, by the way, thankfully, but with the flu. And so he missed that test. And later on, when he went to Professor Saha and told him that he was sick and therefore missed the test, Professor Saha said, nothing doing. You guys have all such excuses. You do not have this dissertation option open to you anymore. Now AKR was in a fix. What would he do? What would he take as a special paper? And he had heard that with crystallography, apparently at that time, one could get very good marks. He chose that in his disappointment. As Tinto already mentioned, AKR was awarded the Doctor of Science, the highest degree of Calcutta University, based upon a dissertation which included discussion of the Raychaudhuri equation and the recommendation, the glowing recommendation was given. But between the Master of Science and the Doctor of Science, there is a story to be told. And this is what I intend to do now. Now, many of you would probably know the story better than me. And so, please pardon me to get some of the facts incorrect. I shall try to, well, you can always stop me and give a rejoinder. You're welcome to do that if I stop. So AKR was not like, a student who was blazing with flying colors and would go through research without any problems. In fact, it was quite the opposite. He first joined Professor Kuleshkar. Now, when he was a student at Presidency, Professor Kuleshkar was the most impressive as far as he could recall, because he did all the steps in his derivations with meticulous detail. So AKR felt that he was a man who was extremely careful and who paid attention to detail, so this was a guy to work with. However, within a short time, there were differences. Now, these differences were actually intellectual differences. They arose because of certain habits he noticed on part of Professor Kaur. In particular, what really produced this change of decision, a life-changing decision, was this thing about Bessel functions. Now, all of you are familiar with Bessel functions, I'm sure. There is, of course, an asymptotic expansion of the Bessel functions, which works for the argument. AKR, while working on a paper of Kuleshkar, noticed that Kuleshkar was using the same approximation near the origin. So he went to Professor Kaur and said, "Sir, how can this be? This approximation is only valid far away from the origin, yet you're using this same approximation to determine the physics near the origin." Apparently, Professor Kaur said, "If you are so finicky, you shouldn't be in physics." So that was the end of AKR's tenure with Professor Kaur. And of course, there was nothing else to do. Here was an MSc student. He had got spectacular marks in MSc. Now, then he decided to cash on his special paper, X-ray crystallography. Of course, when I say X-ray crystallography, you might be surprised. X-ray crystallography nowadays is a tool. It's not quite a subject. But those days, there was a special paper assigned to X-ray crystallography. And AKR decided to cash in on it. So there was a vacancy of a research fellowship in the experimental solid state physics group. Professor Dash would know about it. That group has now many avatars, material science and this and that. I don't even know what the names are. But those days it was called experimental solid state physics. And this activity, which he started, turned out to be a complete disaster. There were two problems. The first of all, AKR wasn't sure what he had to measure. The research problem was never explained to him, and he was never motivated for research. Now, all of you know, many of you have guided PhD students, and you know that without a proper motivation, a student has a tremendous struggle in his or her front because there is absolutely no reason to do it. Why should you spend hours and hours doing something about which you're absolutely unsure of? Secondly, this laboratory was very poorly equipped, which is unfortunately true for a national level research institute like IACS, was true at that time. Now it's much different. It was true at that time. In particular, I had a similar experience. Gaurav mentioned about my engineering career. One of the things that you have to do in experimental solid state research or condensed matter research is to produce vacua. Because if you do not produce good vacua, then you're obviously not going to be able to study the sample under under clean conditions, so to speak. Excuse me. And it turned out that the vacuum pump, which was assigned to AKR, had a leak. So months and even years went by, AKR trying desperately from morn till noon, till dusk, trying to get the vacuum, which he never got. So it was quite a disaster. And after 5 years, there was absolutely no progress. So according to the rules, the fellowship had to be terminated. But, and this is the key, while this disaster was happening, AKR was not being lazy. He was not spending time drinking chai or worse, drowning his sorrows. He was doing extensive self-study in theoretical physics, which was, after all, his real love. At that time, IACS, it still does, IACS had a splendid library. I have been to that older library. It was wonderful. Beautiful collection of classic books. And AKR immersed himself in the studying of general relativity and quantum mechanics. So AKR did not waste the time. He was fully and completely in line. He was getting ready for a career in theoretical physics, even though he was getting a fellowship for a project in experimental solid-state physics, which was going down the drain. So it was kind of weird. But then when it got struck out, AKR wasn't. Obviously, there was super PhD and asked for financial simply not done. So he had to look for a position, and he found a position, a temporary lecturer's position at Ashutosh College. And because of his self-study in general, he could go over to Professor Nikhil Ranjan Sen's seminar. If everybody is with me,
Yeah.
everything okay?
Yeah,
I'm checking because sometimes my computer does funny things.
Now, if you can speak little louder,
Okay. I'll just come. Yeah. Is it better now?
Yeah.
Is it better? Am I audible better?
It is better.
Okay, great. So now, in this seminar, he was attending these talks, and during one of these talks, he found that he could do something. There was a little mathematical problem in one of the presentations that somebody else was doing, and he figured out a way to do the presentation much more easily. And so he went to Professor Sen and asked him if he could work on this. And Professor Sen was very welcoming, and he said, why don't you go ahead? So AKR actually completed this work and went back to Sen and asked him what to do about it. So this is the key thing. Professor Sen told him that, look, you now a result, you have to communicate it. And he said that Bulletin of the Calcutta Mathematical Society would be a nice communicated. But have you written a paper? AKR said, no, this will be my first if it works out. So NRS, Nikhil Ranjan Sen, said, I will write the paper for you. But NRS did not put his name on the authorship. So I think that Nikhil Ranjan Sen, by the way, those of you who may not have heard this name, he Shotendranath Bose and Meghnad Shah in the same class in applied mathematics. He was Shotendranath Bose, the second was Meghnad Shah, and the third was Nikhil Ranjan Sen. So he was in that category. Very well-known professor, held many important positions, academic discipline throughout his life. And when to this young fellow who had absolutely no credentials, he said, I'll write the paper for you. AKR was quite overwhelmed. The paper came out. That was his first paper. But on questioning AKR, I could not get much out about the subject matter of the paper. However, all was not well, because as time went along, AKR started getting his own ideas. So he would approach Professor Sen every now and then, and he found slowly that Professor Sen wasn't very receptive to this bubbling youngster, speaking out all sorts of funny ideas, many of which could be crazy. This was not a place to be in anymore. He said he was not gaining much of it, and so he was solitary once more. But he was uncompromising. He was teaching at Ashutosh College, but because he was a temporary lecturer, his teaching load wasn't enormous. He had time to think of things that he wanted to do. And the inspiration came from Einstein, the great Albert Einstein, who was actually not very well in the 1950s, but he was, his paper, the paper which caught AKR's attention, went back to 1939. It concerned what is called the Schwarzschild singularity. I shall talk about this in a little more detail. And Einstein's claim was that the Schwarzschild singularity was unreachable beyond reasonable doubt. AKR, in his paper, mind you, mentions that he had unreasonable doubt about this claim of Einstein, and he was able to argue that the Schwarzschild singularity, which Einstein paid so much attention, is actually unphysical. In this same paper, which was published in 1953, it was written in 1952 June, to Physical Review, finally appeared in 1953. AKR drew attention to the real problem, the physical singularity at the middle. Okay, in the middle of what? So let me now take a little digression. I am starting with special relativity, although most of you know about this, but because Professor Das mentioned a few students, I'm just beginning with the light cone. So the blue lines with arrows indicate light rays in space-time. The dimensional plot which I'm showing here is a space-time. So every point is actually an event with a space-time coordinate. Actually, there are 3 space coordinates, but I just couldn't draw 3 axes here. So I've just presented one. Now, on the light rays, the blue lines, x is always equal to ct. For all the other events, which I have drawn here, x is less than ct. And the pink hyperbola represents only one event as viewed from different reference frames. So it's the same event as viewed from different reference frames by different observers who are related to each other by Lorentz transforms. So different inertial observers. And what I have depicted in this diagram is what we call future light cone, because you can see the time going up. There's also another part of this down, which I have not drawn, which is called the past light cone, which is identical to this, but with the arrows going down like that. Okay, let me skip this part and go over to curvature. So you see the space-time of special relativity assumes that you have a space-time continuum, by which I mean there is no event which is not given a space-time description. But in that geometry of space-time, it is called a flat geometry. Let me explain that in a second, but before that, I remind you that spatial curvature is actually very well known. If you take a bed sheet and 4 of us hold one each corner such that the bed sheet is tight and flat, and somebody else drops, immediately you see there's a curvature which develops in the sheet. That is space curvature. However, this is Albert Einstein. He was in what is called space-time curvature. So from space diagrams, we go to the space-time diagram. On the left of this little panel, the little panel on the left is a repeat of the light of special relativity, so that each diagram looks like every other. They're all parallel, they're all sitting nicely. This line in the middle, is this cursor visible, please?
The cursor is visible.
Okay,
yes.
So this line in the middle, you're supposed to think of it as time going up, time increasing in that direction up there. And now on the right-hand side situation where there's some heavy object here, some source of gravity, and you can see the immediate change in the light cone diagrams. The light cones actually bend. So suppose you are sitting here, you have from this point, if a ray of light came here, you would receive it at this time. You're just sitting, you're not moving at all, you would receive it here. From here, you would receive it here. Just extend this arrow, you receive it here. But if somebody lit a light here, this would go on and on and on, and because this goes on, so you receive it way up there somewhere, and this, you'll receive at such a late time that you may not even hear it. It may be past one's lifetime. So what we see here is that the light cone's bending amounts to bending of light due to space-time curvature. Another way of saying it is that this bending of light cones is the signal of space-time curvature. Of course, the curvature increases as you approach the gravitating object, and it increases smoothly. There is no jump. There is nowhere that the curvature becomes infinite. So the curvature always increases smoothly as you approach the gravitating body. What causes curvature? Well, here we are. So what we are saying is that gravity is now being redefined by Albert Einstein as space-time curvature. And the Einstein equation tells us that space-time curvature is this constant. G is the Newton's constant, C is the velocity of light times energy, momentum, density. A part of this, of course, will be an object with mass, which has both energy and momentum, but there are also particles without mass, which also have energy and momentum. They also will cause space-time curvature. So this is the essence. So it is a continuation of the space-time continuum, but now with extra properties. So how are we to determine how the space-time curvature determines planetary motion, influences planetary motion? And here we are. This is the sun. And you can see elliptic motion, but it's a kind of strange kind of elliptic motion. There are so many ellipses. What is going on? Now this elliptic motion arises, the sun is pulling at the planet. But because the space-time curvature, planets have no option but free this curved geometry, curved space-time geometry. But what about this multiplicity of ellipses? Well, enough. What you can show that actually the curve never closes. The ellipse. This is called the precession. Another important property, which is light, which is weird for mass. So why should it bend in a gravitational field? Now, this was predicted by the general theory of relativity by Albert Einstein. Only about 100, there was this observation of this, one in Southern Africa and the other one in Brazil, were able to see this light and the sun, solar eclipse, of course, because if it's the sunlight, you won't see. But during the solar eclipse, when the sun, the light was by the sun, and this particular experiment in 1919 was what heralded Einstein to overnight, I should say. Within one night, he became who was Schwarzschild? Well, he was a physicist who was unfortunately put into the First World War. He had to fight in front against Russia. And it was a disaster because they were trying to find a solution of Einstein's equation. General relativity had appeared in 19. The only thing that Schwarzschild curvatures. This is one of the mysterious things about general relativity which we have to our students. It's amazing how this happens. There are two or three different kinds of curvature. One of them may vary. We'll try to generate which has a spherical structure, which is equipped with a length scale, which I call its radius. Look at this spherical area, Look at this spherical region of space. Rotating star or whatever object, could be any metal object. It's as of space, and it's a geometrical region. There's nothing inside. It's as if rotating object with a mass m. The simple equal to gm. Exactly the kind of motion. So you can see that there's a precession projected. This is what is at the focus. So instead of this being the sun, you now have this empty region of space. Empty region. But there are properties of very bored of my lecture and you decide to throw me into this spherical region.